if you're just tuning in now, we are going to talk about wildfires and climate change. And I'm joined here by Dr. Liz Hoy, a scientist at NASA's Goddard Space Flight Center. She studies the Arctic and northern regions and how fire affects those areas, particularly in a warming climate. So I've been really looking forward to this talk because it's officially wildfire season. And we're hearing more and more about that in the news. So hopefully this can give us a little bit more context to what we're hearing. So thanks for joining us, Liz.
Well, thanks for having me.
And for those of us that are tracking the season, it does seem that wildfire season is getting longer, starting sooner, ending later. Is that true?
Yeah, that absolutely is happening. We're seeing wildfires that are starting earlier in the spring and lasting later into the fall. And this is happening in a number of different places across the globe. One thing we're seeing in northern forests, which is really interesting, is this phenomenon called zombie fires or overwintering fires. And these are fires that actually burn late into the fall. And then the snow comes, it covers up the fires, but they continue to smolder underground all winter. And then as soon as the snow starts to melt, the fires pop right back up again. And so you get this really early spring fire. And it's one of the reasons that we are having these early spring fires. So it's something that we're really trying to learn more about and study in northern forests especially.
Wow. So these fires that are kind of shadows of previous seasons and making their way earlier and earlier into the next season. And with a longer fire season, do we see more fires? Is the number of fires increasing as well?
You know, it's interesting. We aren't necessarily seeing more fires. We're just seeing that these fires are larger. They're burning more area. Sometimes they're happening more frequently. But if we look at kind of global trends of fire, we're not actually seeing a greater number of fire. If we think about California, for example, well, I like to think about human-caused fires and kind of natural fires or fires caused by lightning. So if we think about California, we have about an equal amount last year of human-caused and lightning-caused fires, and actually a pretty split amount of the number of acres burned across both of those different types of fire. But if we look at a place like Alaska, where fire is really a natural part of the ecosystem there, and actually some seeds of trees there actually don't open until after fire. And there we see that we have more fires caused by people, but overall the area burned is greater from the lightning caused fires. And so it's kind of it's a different kind of phenomena that we see in northern forests there.
So fires burning larger and possibly longer in different areas.
Yeah.
And how is climate change impacting that, which is what we're seeing?
Yeah, so to have a fire, you need three things. You need heat, you need oxygen, and you need fuel. So heat is just an ignition source like lightning. You need oxygen, of course, and then the fuel is like forests or grasses. And so what we're seeing with climate change, we're seeing these warmer and drier conditions. So our fuel is more dried out, it's more available, it's more ready to burn. You know, if we think about what our global climate is doing, 8 of the last 10 years have been the warmest years on record. So, and that's a record that's been going back since the late 1800s. And so we're really just seeing that as temperatures are warming, we're making this fuel more available to burn. Our weather is changing. We're seeing more climate extremes across the globe, and that's can be leading to more severe and intense wildfires, larger wildfires, and more frequent wildfires.
And is that something that we saw coming? Is it expected, all these changes that are happening?
It's certainly something that we now have the tools to better understand. And we have tools now to, NASA satellites to even study aspects of climate as well. We study whether climate change is happening from the oceans. Is it the atmosphere? Is it from volcanoes? We have different tools to understand that. And what we're really seeing right now is that the climate warming is coming most of it is coming from human causes. So we're just putting more energy into the atmosphere, it's staying there and creating this warming that we're seeing now.
Right, and there are particular fingerprints, right? I feel like that's a word that's been used about the way we know that this is human-caused climate change. Can you speak a little bit about that?
Yeah, when we're using these different tools and satellites and modeling techniques to understand different aspects of climate, we can kind of see these fingerprints of each kind of climate driver. So we have drivers from ocean currents and changes, and drivers from atmosphere, and they each have their own kind of unique changes that cause changes in the fluctuation of temperatures. And so we can really see that these fingerprints are, right now, what we're seeing in climate warming is these fingerprints are the human fingerprints that are really causing more energy into the atmosphere, and thus kind of this accelerated greenhouse effect.
And to our viewers that are tuning in, if you're interested in diving more into these fingerprints that we are talking about that show human-caused climate change, make sure you check out climate.nasa.gov for the latest on that. So we hear about these wildfires and the effects that they have in the areas that they're burning in. Can you tell us more about how they might be impacting more areas than we might initially think?
Yeah, absolutely. So when a fire is burning, it's of course impacting the people and the landscape right where the fire is happening. It's impacting human health there. It's impacting, it can have economic impacts. It can really cause severe impacts to the people that are in that region, even death sometimes, unfortunately. But the impacts aren't just isolated in that one location. The smoke from wildfires can travel hundreds of miles and can affect people far away from where the fire actually burned. Also, that carbon that's emitted from the fire, it's going into the atmosphere, it's creating this warming, which can then cause more fire down the road. Another impact we see is that as the smoke travels, it can be deposited in other places. Like, for example, it can even go to Greenland, be deposited on the ice sheets there, and cause melting of the ice sheets there, and actually more warming that way. So there are a lot of impacts from fire, and they're not all in just one place. I even like to think about like a personal example. So a few years ago, there were some wildfires in Canada, and the smoke traveled to actually where I live in Maryland, and people that I know were having difficulties with asthma because it was difficult for people around here to breathe, even though we were hundreds of miles away from where the fire first happened.
Wow, very far-reaching effects, definitely.
Yeah.
Now, it is also NASA's Earth Applied Sciences Week. So I have to ask, because we have a lot of different missions, field missions, satellites that give us more information about wildfires, but how do all these data really help us to manage wildfires?
Yeah, I'm really glad you brought this up because, of course, when people think about NASA, a lot of times the first thing they think about is rockets going off into outer space. And of course, NASA is definitely doing some amazing research in outer space, go James Webb. But we're also looking back at the surface of the Earth. So we have over 20 Earth observing satellites, that are designed to look back at Earth. And a lot of them they're able to see different aspects of wildfire. So we can see the extent of a wildfire, like where it's burning on the landscape, its size, its frequency, how the severity of the wildfires. We can also use some of these tools to look at one that I really like is it's called the Fire Information Research, FIRM's Fire Information Research Management System. And it gives almost near real-time information about where fires are burning. And that's one you can find on www.earthdata.nasa.gov and search for FIRMs. But you can get information there. It's like 3 hours or less from when a satellite overpass occurs. So for fire managers that are managing fires in remote locations where it might be difficult to see a wildfire cropping up or just over large distances, that satellite view of wildfire can really help get resource managers the information they need very quickly to start managing a fire. And if they need to get crews out there, they can do that very quickly. So that near real-time aspect is really important. We can also see aspects of soil moisture in both the ground and even in vegetation, the moisture of vegetation. And that can help resource managers to understand where they might need to be prepared for fire to occur if the conditions are very dry. So there's a lot of different ways NASA data can be used by resource managers.
Yeah, really important work bringing that data down to the ground, to the people that are facing this every day, especially during the season. So switching gears a little bit, I know that you're headed out into the field yourself soon with the Above mission. Can you tell us more about that?
Yeah, so I work with the NASA Arctic Boreal Vulnerability Experiment. It's a mouthful. It's ABOVE is what we call it for short. and which we love because, you know, we're looking at the Earth from above and we're kind of in northern areas. We're above everybody, you know, above a lot of the globe. But what we're really trying to understand is the impact of the environmental changes that are occurring in these northern areas like Alaska and Western Canada that go along with climate change. And so we're looking at things like permafrost thaw and disturbance. And of course, fire disturbance is one of the big ones that we're really trying to investigate. But we have teams on the ground taking field measurements. We have airborne sensors that we fly around to take measurements, and we can see soil moisture, changes in vegetation, changes with permafrost. And then, of course, we're using satellite imagery, like those 20 satellites that we said are out there. And then we're kind of putting it all together in models to better understand these changes. And so when I go up there, I'll be helping to do some of the field work, but I'll also be flying with some of our aircraft as we make these measurements. We kind of fly around the domain and make different radar and LiDAR measurements, which are just different ways to look at vegetation change and permafrost and fire disturbance.
And we're looking forward to sharing a little bit more behind the scenes of what that work is like when you're out in the field. So more to come on that. But why is it important to study wildfires in these particular regions that you'll be looking at?
Yeah, and that's a great question. You know, the Arctic areas, these high northern areas, they are changing. The global temperatures there are changing at 2 to 3 times the rate that they are elsewhere around the world. So we're seeing some really intense environmental change there, intense climate change, intense environmental change. And we're trying to really understand how it's changing and where it might be going, what's happening next. So when we're thinking about wildfires, we're thinking about as we see fires burning there, are we going to actually change some of the ecosystems there? Are we going to come back as forests, or is it going to switch to shrublands? How is that going to impact this area where people are living, where people are relying on the land? But then also, how does that change impact where we live in the rest of the United States or across the globe? And trying to put some of those different pieces together.
Well, Liz, you've given us a really great overview of a lot of great context to take into wildfire season as we're hearing these things pop up in the news. But I think some of our viewers might be taking this information and saying, what can I do with it? How can I help? So what advice would you have for that?
Yeah, I'm really glad you bring this point up because, you know, a lot of times it can be kind of difficult to take in or try to understand, or like, what can we do? I'm only one person. So what I like to think about is that we all wear different hats in our community. Maybe you help with after school activities, or maybe you're a member of a religious organization or a civic organization. But you all are also here listening to us talk about this issue, about what the environmental impacts are with fire disturbance and climate change. So this is something that you obviously care about. So what I like to do is I tell people to just, you know, you're here, you're learning, you can take this information back to your community and share with them and have a discussion. And it's through these discussions that we can all move forward together. And this has happened with other issues throughout time. We've tackled the ozone layer together and other, you know, harmful chemicals. We've seen legislation and changes to help with that. So there are ways to move the conversation forward. And I think learning is one of those ways that we can all start talking together.
Absolutely. And thank you to you for kicking off this conversation today. If you're watching this and you want to learn more, make sure you are following us here, NASA Earth and NASA Climate Change on Instagram, Twitter, and Facebook. We'll be sharing more resources throughout the season. So thank you so much, Liz, for joining us today. And thank you everyone out there for watching.